And the right sequence, in fact, you can code this is CDMA, so it's code. So all code and spread and then display. I think we have the discussion in chapter 1, right? Spread, so we have a wider one. And multiply the code again, then we can get the original one so that we can recover. And recover, so we will have this. So we can display. Well, look at the current figure and think about narrowband, spread, and narrowband again because we display. Why we want to display? If we can display, we can spread, not display, right? If we can spread and then we have a wider one, and wider one seems to be we can hide the signal perhaps in the noise. If we have this, actually we can have a type called white noise. Right? So something like we want to have the concept maybe for security issue. We don't want to let the other even. It doesn't mean we have something like that. But something like we have a white noise and we have a signal similar to white noise, but put that together. You think we cannot recover? No, we still can recover. So we can recover it. And actually, this phenomenon, in fact, it was developed by military field in the United States. So that's why they prefer these. Because they prefer these, so they expect it, and so they expect spectrum. So we have an SS. And to have an SS, the first one we can pass on the right sequence. That says we have a code. Alright, so this is first one. And actually this one discussed in chapter 1 already. Alright, we need to have the code. And then we need to have a set of orthogonal code. How to have a set of orthogonal code? We have the way to generate. It is called wash codes. To have a wash code, this is a way to have a wash code. Initially, we have, for example, we may have a 0. And next one, we have this. So this is a procedure, initial one, and the relationship and this matrix is called Dharma matrix. And Dharma matrix allows us to have these. Finally, all row vector forms the orthogonal vector. All right, so right now we want to introduce a Dharma matrix to have the wash code and wash code to have the orthogonal codes. And for example here, we have a wash code, and wash code, and they are orthogonal. So how to have that? Actually, we can start from H0, and then H1. So H1 we have a 2 by 2, and H2 and H3. To H3, then we can have the 8 vector. So right now, if we have H3, so how to have H3? And suddenly you can have the orthogonal poles. Well, if you have an empty paper, you can try this. So I highlight this. So how to have H3? You can try. And finally, you can have 0 denoted by -1 and 1 denoted by 1. And sometimes we have the reverse setting. 0 denoted by 1 and 1 denoted by -1. Either one will be okay. But right now, let's try. Maybe not to 3, maybe to 2. So at least from H0, so we should have H1 and H2 and H3. So you can try how to have H3. All right, you can try it. Starting from H0. H0, we can have a matrix 1 by 1 matrix is 0. So you can continue to have the others. So right now you can try it. Later we can have the matrix. So all of the goods you can try this one. I allow you to have 3 minutes to construct H3. Construct H3. So what is the vectors of H3? Here we have this bar. Bar means the complement. Right? So 0 and then you have 1. I emphasize we have a complement. N plus 1 after we have a complement. And then you can construct. Of course, H0, we just have a single one. So is it an orthogonal one? No. You cannot use it to have the orthogonal one. And we will have H1, then we have the orthogonal one. You can try. Our mission is construct H3 matrix.